All right, welcome to your next in their video series on chapter 14 with acids and bases. We're going to be talking about pH and pOH today with a little bit of buffer stuff kind of thrown in as well. First thing we need to do is review a little bit on concentration. Remember concentration, we started with our little joke on, the orange juice container where we said, why did you stare? Because it said concentrate. Haha. Okay, so quick review. Remember we called concentration, our measurement for it was molarity, which was moles of solute per liter of solution. Remember the difference between that and solubility? Solubility was just whether or not the substance will or won't dissolve. Okay? Well, our tie-in for pH from concentration is that pH actually measures the concentration of the hydrogen ion. And remember, hydrogen ions are simply H plus ions. Okay? Now, this is what we call a logarithmic scale or a log scale on most scientific calculators, which you're going to want a scientific calculator as we keep going. So if you need to pause the video and go find one, that's fine. But on most scientific calculators, there's a log button that you're going to need to be able to use. pH is the negative log of the hydrogen ion concentration. So what I want you to do right now is try to find a calculator, and then we want you to try to practice one problem really quick with me. I want you to tell me if the concentration of our hydrogen ion is 0.001 molar, what's the pH of the solution? Well, for some calculators, you're going to put this number in first and then hit log. Some, you can hit negative log and then put this in. It kind of depends on your calculator. What you have to be able to do, though, is to make sure that you can get the pH of this solution, which the pH comes out to be 3. Okay? So on your calculator, make sure that you can get that for the pH. Alright, so if you have any problems with that, you're just going to have to try to email me or come in sometime tomorrow and just have me look at your calculator, and I'm sure we can figure it out real quick. Okay? Basically, one of the easiest ways to look at this is you kind of count. As long as the number for the concentration is 1, you can kind of get away with just counting how many places did you have to move a decimal. But what happens is if it starts changing the number, then that doesn't work. So make sure if you can't get your calculator to come out to a pH of 3 that you come in and kind of talk to me about that. Alright, so what I want you to do, if you have your calculator handy, is that I want you to practice a calculation, and then in the form below, again, make sure that you enter the answer to the question. So I want you to figure out, all right, what's the pH of a 0.1 molar hydrochloric acid solution? Is it A, 1, B, 0.01, C, 100, or D, 0.1? Pause the video, punch it into your calculator, and then answer in the form below. Alright, now as it turns out, we can actually do the same thing for bases. Now most of you probably have heard of pH, but you haven't heard maybe of pOH. Well, it's the same thing. pOH is a measurement of the concentration of hydroxide ions produced by the base then. It's still a logarithmic scale, and its pOH is negative log of the hydroxide concentration. So it's still just negative log of your concentration. The difference is, remember this time, you're going to be looking at formulas that have an OH, and I'm going to be giving you concentrations of hydroxide ions instead. Okay? Now water, if you remember, some of you may from physical science, some of you may not, water is in neutral on the pH and pOH scale. Acids, in case you have forgotten, acids have a pH from 0 to 7, and then bases go from 7 up to 14. Well, water has a pH and a pOH, if we want to throw that in, of 7. So what happens is any time then that we have to try to figure out, okay, well, if I know a base, I can figure out its pOH. Well, how do I determine what its pH is? Well, the two numbers always add up and equal 14. Again, 7 and 7. If we're dealing with water, they always add up to 14. Okay? So anytime we're dealing with a water molecule or water in general, remember pH is neutral, 7, and then anytime we're dealing with either an acid, something that's got an H, or a base, remember something that's got an OH, and we wanted to figure out the opposite. If I wanted to know, okay, well, what's the pOH of an acid? Remember, the two numbers will always add up to 14. Now, the one thing I want to make sure I get completely clear, because what happens way too often is that people think that pH and strength are the same thing. pH does not mean strength. Remember, strength is how well an acid creates hydrogen ions. It has nothing to do with the amount or the measurement of them. pH just measures how many are there. So what I want you to do in the short answer section is, can you think of a way where a weak acid could actually have a lower pH than a strong acid? Okay, make sure you understand the difference then between concentration, the amount, and how well the thing breaks apart or creates ions. All right, see if you can come up with a way that a weak acid could have a lower pH than a strong acid. All right, last thing we got to talk about then is buffers. Well, buffers are a specific or special case where they try to resist change to your pH and your pOH. Most common one that you'll come in contact with is your blood. Okay, blood again is a common buffer. It has a pH of around 7.2. It's just slightly to the basic side. Okay, what happens is if your body starts to get a little acidic, blood can counteract that by behaving like a base and kind of neutralizing it a little bit. And if your body becomes too basic, blood can kind of behave like an acid and neutralize that as well. Okay? Remember, we said substances that have the ability to behave both as an acid and as a base are what we call amphoteric. Okay? All right. If you have any other questions for me, make sure you fill those out in the bottom below of the form, and then again, put your name, your email, all that stuff in there so that I can respond. That's it.